Hey everybody, it's Miss Berry. In this video, we are going to cover section 1.4, which is called perpendicular and angular bisectors. So let's begin by talking about the definition of a perpendicular bisector. A perpendicular bisector is defined as a line that crosses a line segment at its midpoint and then forms a right angle where it crosses. So imagine that we've got a line here and we're just going to put mark a little line segment on here. So we've got A to B. So the line in between A and B, that's our line segment. So a perpendicular bisector would be a line that is crossing this line segment at its midpoint. So I'm going to shade in between these. So that's our line segment. All right, so a perpendicular bisector is going to be a line that's going to cross this line segment at its midpoint. And it's going to form a right angle where it crosses. All right, so we've got a little right angle here. So we know two pieces of information here. We know that this perpendicular bisector splits the line segment in half. So the distance from A to the perpendicular bisector is the same as the distance from the perpendicular bisector to B. And we also know that this is a right angle here, which is also going to force this to be a right angle. Down here's, sorry, I just realized you can't see my pointer. So here we've got a right angle. It's going to force this angle here to also be a right angle, the angle below. So each one of these little angles becomes a little right angle. We've got something called the perpendicular bisector theorem. It's very useful. It says if a point on the perpendicular bisector, let me start over. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. All right, so this is definitely going to be easier if you just look at a picture. So let's go ahead and get our picture up. All right, so let's say we have our perpendicular bisector. We know that's a right angle. All right, so it says if a point is on the perpendicular bisector, all right, so if a point is on the perpendicular bisector, I'm just randomly placing it up there. You could put the perpendicular bisector anywhere on this, or you can put the point anywhere on this perpendicular bisector. So you could put it here, you could put it a little lower, you could even put it down here underneath the line segment. All right, so if a point is on the perpendicular bisector of a segment, then it is equidistant. All right, so this point is equal distance from the endpoints of the segment. So that means that this point, let's call it P, is the same distance from A as it is from B. All right, so those two line segments are equal. All right, so I'm going to throw up those little line segments there. So the length of those two line segments is the same. And this goes for any point on the perpendicular bisector. So you can scoot that point down, redraw your lines. Those two lines are going to be the same length. All right, so those two line segments are going to be the same length. This is another version of the picture that you could draw for perpendicular bisector theorem. So I just wanted to show you another version of that, like a more official version. I grabbed this out of a textbook. So you can see here we've got this line segment P to R. PR is the line segment. Then we've got a perpendicular bisector. You can see that it's forming a right angle here. And it says that anywhere that you place a point on the perpendicular bisector, here they've got it labeled as Q, that's going to form two line segments that are equal in length. All right, so PQ is equal to QR. All right, so let's put the perpendicular bisector theorem into action. It says, use the given figure to find the length of the line segment AB. All right, so according to our perpendicular bisector theorem, you can see that here BD, that's our perpendicular bisector because it's forming this right angle here. It's got this line segment AC split into two equal chunks. All right, so that is the definition of a perpendicular bisector. All right, so the perpendicular bisector theorem tells us that the line segment AB is going to be equal to the line segment BC. All right, so those lengths are going to be the same. All right, so that tells us that 4x is going to be equal to 6x minus 10. So let's set those two values equal to each other. All right, so we have 4x equals 6x minus 10. We're just going to solve for x here. We need to figure out what x is. X is not the answer because they asked us to find the length of the line segment AB. All right, so x is not the answer, but x is going to allow us to find the answer. All right, so let's solve for x. So we're going to subtract 6x from both sides. It's going to cancel out on the right. On the left-hand side, you have negative 2x. On the right-hand side, you've got a negative 10. Don't lose that little negative in there. All right, then we're going to, again, we're trying to get x by itself, so let's divide both sides by negative 2. It's going to cancel out on the left. And that's going to leave x by itself on the left. On the right-hand side, negative divided by negative is going to give us a positive. 10 divided by 2 is 5. All right, so there's the value of x. Now, x, again, is not the answer, but x is going to allow us to find the answer. All right, so we're looking up here. We're looking up here at our line segment AB. That's what they asked us to find, the length of the line segment AB. All right, so the length of AB is 4 times x. We know that x is 5, so go ahead and plug in 5. So that's going to be 4 times 5. So the length of the line segment AB is 20. All right, another similar problem. I want you to pause the video here, try this on your own, and then come back and check your answer. All right, so pause the video here, use the same technique as the last time. Notice here that it just says find the value of y. All right, so I'm going to give you a second to pause the video, then you can come back and check your answer. Okay, so if you're coming back to check your answer, it says find the value of y. We can see y is used twice here. We've got y as representing the length of the line segment JM. It's 6y minus 16. And then the line segment KM is has length 2 times y. So we're going to set those two values equal to each other. We're allowed to do that by the perpendicular bisector theorem. All right, so you can see that MB is the perpendicular bisector. It is splitting this line segment JK into 2 equal chunks, and it's forming a right angle. So that is the definition of a perpendicular bisector. All right, so now I'm just going to try to get y by itself. So I'm going to move this 6y over. If you prefer to move all the variables to the left-hand side, that's fine. But I'm going to subtract 6y from both sides. That's going to leave me with negative 16 equals negative 4y. Divide both sides by negative 4, and that's going to give us y equals positive 4. And again, we didn't need to plug anything in here because they were just asking for the value of y. All right, so we're done. All right, the last topic is angular bisectors. So the definition of an angular bisector. So it says an angular bisector is a line that goes through the vertex of an angle, and it divides the angle into 2 congruent angles, so 2 little equal angles, that each measure half of the original angle. All right, so imagine that you have this angle here, and let's say that this angle is 46 degrees. An angle bisector would be a line that went straight through the vertex right here. So a line that went straight through the vertex, and it would divide that angle into 2 equal chunks. All right, so instead of being 46 degrees now, we were going to think of it as 23 degrees and 23 degrees. All right, so each of those angles measures half of that original angle, which was 46. So 46 divided by 2 is 23. All right, so let's use the what we know about angle bisectors to find the length of the line segment TK. All right, so we've got this kind of complicated spider web looking diagram here. So you can see that CS is an angle bisector. It has split this big, huge angle into two equal chunks. We've got 26 degrees up here, 26 degrees down here. I know that because they've got the angles marked as congruent. All right, we are asked to find the length of TK. So TK. All right, so there's TK. And you can imagine that since this is split in half, this is kind of creating two, like a mirror image of itself. Like you could fold it in half across the line CS, and it would be a mirror image on both sides. All right, so TK is going to match up with TD. And so since the line segment CS is an angular bisector of this big angle LCQ, then I can use the fact that this is forming a little mirror image across that line CS, and we know that TK would be the mirror image of the line segment TD. So the length of TK would be 23 degrees. And I'm kind of being a little lax with my notation here. I should not have this line up here if I'm talking about the length of a line segment. Let me just take that off, or try to anyway. I keep losing my pointer. Whoop, there it was. Y'all, I'm all over the place. I can't tell where my pointer is. There we go. All right, so really, if I'm being careful with my notation, then the length of TK is just described by the letters TK. So I don't need the line segment notation there where I have the line above TK. All right, and then our last problem here, it says use the given figure to find the length of the line segment MB. All right, this actually is a perpendicular bisector. I see that, let me change over to my laser pointer. NM is a perpendicular bisector. You can see that it splits AB into two equal chunks, and it forms a right angle. All right, and so this is asking me to find the length of MB. Well, it's got it marked here as being congruent to AM, so I know that MB must be 5. So these problems are really all about just being able to read the diagrams, knowing what you're looking for, and then also remembering the definition of what an angular bisector is and what a perpendicular bisector is, and how to be able to spot those whenever you're looking at a diagram. All right, so that's everything for section 1.4. If you have any questions over this section, please email me and let me know, and I'll see you guys in the next video.